Okay, and we're back here at Stanford Systems. I have the space for it. You notice I have my flags up. The flag on the right is going to be a Mexican flag. I want to show my desire for peace between the United States and Mexico. This here is an achievement for me. One of the big things in my life is that I honestly feel and felt that I could have won the X Prize if I hadn't have contracted schizophrenia back about 10 years ago. So actually building this thing, even as a mock-up, is a really vindicating event for me. This is something called the drogue module. Okay, now it's the simplest module in the entire design, but it's coming together really well. What I've been doing is testing the aluminum skin layout with cardstock, and when I'm finished, it's going to have every single rivet in the right spot. Okay. Now, you'll notice that this is a detailed mock-up. I wanted to see if my actual design was viable, if that makes sense. You'll notice it's done entirely in foam board and cardstock. But it's starting to look beautiful. The frames that hold it are an example of dynamic stability. One of the things I was struck with is the beauty of the frame that's used to mount. What I did was I took apart the last frame, and what I'm going to do is have a frame for each module. It puts a big gap between the various modules in the mock-up, but allows me to work on it. It allows me to take it into the kitchen and hot glue it up there. Okay, this is a more complicated module. Okay, it's going to be done the same way. The external is done in thin wall mild steel, and it mounts the instrumentation frame, it's called, right off of the pillars. Okay, this is an example of something called pillar I-beam construction. So this is the instrumentation frame. It's done in TIGGed aluminum. I'm working right off of the engineering prints. So everything is to scale. These are the monopropellant tanks for the attitude control system. These are something called the instrumentation cans. Okay, I want you to take a look at this. Basically to get around having to test every single electronic component in a vacuum, what we do is we put it in a hermetically sealed canister like this, and it has inverted hemispherical bulkheads on it. And we put the electronics and the batteries in here in something called an instrumentation cage, like this. So it'd be batteries here, and it'd be flight electronics in here.